Hello class. Today we're going to be talking about stoichiometry. Stoichiometry is a kind of a mysterious word to a lot of students, and they get a little frightened of it. But there really isn't really much to be afraid of. Just like this picture says, we're going to be looking at chemical reactions. We're going to quantify how much reactants take to make a particular product, and vice versa. So it's really just quantifying or measuring the amounts of reactants and products in a chemical reaction. More precisely, quantitative aspects of reactants and products in a chemical reaction. So it's really all about chemical reactions. How much of this, how much of that, how many moles of this, how many molecules of that. And you know your way around the periodic table pretty well by now. You've been balancing equations for some time now. You've also been doing mole conversions. You know what a mole is. So all of those things are coming into play to do stoichiometry. So here's our first problem. How many moles of chlorine gas would react with 5 moles of sodium according to the following? And when you see a reaction like that, always check to make sure that it is balanced. And I'm not so sure that it is, because if we were to take a look at this, and let's go ahead and balance it, sodium, there's 1 molecule, chlorine, there are 2, because of this 2 right here. And then we have sodium right here. There's only 1. Chlorine, we only have 1. See, it's not balanced. The chlorines aren't balanced. So this needs 2. So I'm going to come over here and I'm going to put a 2. And that makes this a 2 and chlorine a 2. Sodium this side, it's not balanced. So I'm just going to put a 2 over here. And then everybody's happy. We have 2 sodiums, 2 chlorines on both sides of the equation. So there you have it. This one was pretty easy to balance. But I really didn't answer the question yet. So let's take a look. Let's go ahead and put the 2's back on. And let's take a look. It says 5 moles of sodium, and how many moles of chlorine gas would it take to be able to do this? Well, in this particular, let's take a look at what it says first. First, this says we have 2 moles of sodium and basically 1 mole of chlorine. That will give us our yield of 2 moles of salt, or sodium chloride. So it's a 2-to-1 ratio. If you use 2 moles here, then you use 1 here. So it's basically twice as much here than here. So in this particular case, it says it wants to use 5 moles of sodium first. Wants to change that up. So if we use that, we're going to multiply it by the ratio of 1 mole of chlorine gas, and in this case 1 mole of sodium. Shouldn't be 1 mole, it should be 2, because it's a 2-to-1 ratio. So that's 1 mole of chlorine, 2 moles of sodium, because that's the ratio. So you multiply 5 moles, and by the way, this is going to cancel out. So at the end of the day over here, when we're all said and done, it's going to give you moles chlorine. So 5 times 1/2, 5 times 1/2 equals 5 divided by 2, which equals 2.5 moles of sodium chloride. So there's our answer. So you can see in this particular case, that one's easy. Just remember, you look at the ratios. So it takes 2 moles of sodium, 1 mole of chlorine to get 2 moles of sodium chloride. If you up the amount of sodium, you'll have to up the amount of chlorine so that you will get an equal amount of sodium chloride. If you don't, then this is going to become a limiting reagent. It's going to be a kind of a limiting factor there. So not all the sodium will react, so you'll have some left over. And we'll talk more about that a little bit later. So let's go to the next problem. This one's a little bit more difficult. In this problem set, it is balanced. And it's saying that using the previous equation, determine the amount of product which is this, that we want to know how many grams of NaCl will be produced if we use 24 grams of sodium. So again, we're going to change the sodium. We're going to only give us 24 grams of sodium. But we really don't know how much that is in relationship to moles. So we're going to have to look at that a little bit later on. But before we do that, let's go ahead and write this up. So first of all, we know that we want to use 24.7 grams of sodium. Now, one of the things we don't know, or we actually do know, if we had just 1 mole of sodium, what would that be? So if we look up in the periodic table, it comes out to 23. So when you look at the periodic table, it says 23 grams, or atomic mass units. So if we want to take a look at that, well, actually we won't do that, this particular. Yeah, let's go ahead and take a look at it. You can see see the sodium right up there. See, it says 22.99. So that's 23 grams basically. So we have all of that. Now what we're going to do is we're going to multiply this by the fact that now what we're going to do, remember this is a ratio, 2 moles there, 2 moles there. So we're going to multiply that by 2 moles of NaCl, because that's kind of the ratio that we need to work out, because if we're going to add this amount of sodium to get the same amount or the best yield, we also have to, it's basically a 1-to-1 or 2-to-2 if you prefer. And then also we also have 2 moles of sodium. And then what we're going to do is we have to also take a look at what 1 mole of this equals. We know that sodium is 23. We also know chlorine. Let's take a look. Chlorine. Where's chlorine here? Chlorine, if you take a look, is 35. And that comes out to 58. So when we multiply that, we're going to take 58 grams of NaCl, and that comes to 1 mole of NaCl. So let's take a look at that again. This is only 1 mole, but we know there's 2, but that's taken care of by this, because we're going to multiply the what 1 mole weighs, 58 grams, its molecular mass, and then what we're going to do is we're going to multiply it by 2. Same over here with our sodium. We're going to take the 23, multiply that by 2. When we multiply all of that together, that will give us what we're looking for in terms of our answer. And when we multiply all of this, now remember, some of these things got to cancel out. So this right here is going to cancel out. 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 And what we're going to have left over is grams of salt. So when we put that all together, it's going to come out to, let's see here, it's going to come out to, we're going to multiply all of this across, all of that across, so it's going to be basically 24.7 times 2 times 58 grams, and it's all going to be divided by 23 times 2, and that comes out to 62.8 grams of NaCl. So, if you take a look at that again, it's all of this factoring that's really important. All of this unit factoring is the thing that allows you to set the problem up correctly. Now, if you kind of thought through it with basic arithmetic, you probably do the same thing. But this allows us to see what the units are and where they go. So this gives us an opportunity to see, all right, if we put 24.7 grams of sodium in the mix and let it run its reaction, then we would get it would yield 62.8 grams of salt. Okay, here's our next one. This one's going to be a little bit tougher because it has to do with molecules. And on this particular problem set, you're going to have to, of course, deal with Avogadro's number, and that's probably going to be a little bit tough on you. But I think that if you follow through with all the units, it'll make your life a little bit easier on that end. So what we're saying here is how many molecules of product, again, we're looking at this, would be produced at 27.7 grams of sodium. So we've already basically done that. So let me go ahead and rewrite it again. We had 24.7 grams of sodium. Now that one you already know. We're going to again multiply it by, if sodium, we have 1 mole sodium. That is 23 grams sodium. Again, we're going to multiply again by the 2 because remember, this is a 2-to-2 ratio or 1-to-1 ratio, but we need to multiply those by 2 because we're dealing with 2 molecules. 2 moles of NaCl and 2 moles of sodium. And now what we're going to do is we're going to multiply all of that. Instead of the grams, we want molecules, so it's 6.02, and instead of tying in tens, I'm going to just put the letter E, 23, and that equals molecules. And that also equals 1 mole of sodium. And how that all equals out basically is it's going to be 24.7 times 2 times 6.02 times 10 to the 23 divided by 23 times 2, and when you multiply it all out, it comes to 6.7 times 10 to the 23 molecules. So what we're really saying is if we're using 24.7 grams of sodium in this particular problem, we will yield this this amount will be 62.8 grams will actually be, let's see, 62.8 grams will come out to 6.7 times 10 to the 23 molecules of sodium chloride. So That's really what we're talking about when we talk about stoichiometry, is being able to work these equations and work it so that you can find out what the total yield is in terms of grams, molecules, or moles. So just by using all the factoring that we showed you and lots of practice, you'll get better at it. So I hope this helps. We're going to give you a few more problems to work through, and that's the main thing. If you practice, 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 you get better at this. So again, I hope this helps, and we'll see you in the lab tomorrow. Thanks.